Xin chào các bạn sinh viên tham dự Summer School của SN Project. Rất vui chia and have a nice day all the students and participants of SN Summer School. Today I am very pleased to give you some very brief understanding about optimization in smart energy system. This video lecture belongs to SN Project and it recorded in Hanoi University of Mining and Geology, the studio room. However, I'm not so ambitious that I can cover all the knowledge as well as all the important problems related to optimization in smart energy system in only 1 hour and a half. However, I do hope throughout my presentation as well as my video lecture, you can have some brief definition about what is optimization. You also understand about some solution, some mathematics, as well as some software can be utilized to solve the problem, to solve the case study, to solve some real challenges arise in industrial of electrical engineering. Now let's start with our lecture. The content of the lecture focus on the 5 main parts. Why optimization is necessary for the power system. 2. What is the objective function of the optimization problem? And 3. The constraint. The 4th, the solution we can apply to solving the optimization problem. And the last one is some type of optimization problem in smart energy system, including optimal power flow, grid reconfiguration, optimal capacitor allocation. And the last one, I will show you some case for smart energy system grid reconfiguration in Vietnam as well as optimal capacitor allocation. Now, let's start with very brief introduction about optimization. The question is, what is optimization? There are many exercises related to optimization, but now I would like to show you very simple example of optimization. Let's see the finger. In this finger, we have the parabol, and our mission is to find the largest rectangle that fit inside the graph of the parabol and below the line. To show this exercise, you have to identify the first is objective of the exercise and the second is the constraints. The objective is largest rectangle, and of course that the requirement fits inside the graph of the parabol and below the line 8. So the target here is the largest rectangle and the constraint fit inside and below the line. To solve it, we can have very simple solution. We have to find the maximum value of the function represent the area of the rectangle. Now, turn back to the finger. You can see this finger can give you some clue that can form the function of optimizing. Here, for example, make an assumption that we can determine the point A by P. Obviously, we can deduct very easily the other point C and D to form our rectangle. Of course that by using the mathematical transformation, we can have the function A represent the square of the rectangle, and it is the triplet function. To solve it, let's make a derivative, and to solve this derivative, we can have the value of the variable x. Of course that through our example, we can deduct some other. To optimize or to solving the optimization problem, we have to concern and we have to care about 3 following things. The first thing is objective. The second thing is constraints. And the last one, after forming the function of the problem, we can solve this function by using some math solution. So about in electrical engineering, There are many definitions talking of optimization in smart energy system. To answer for this question, we have very general definition. Optimization is a process of interrelated decision on obtaining, operating, and maintaining physical and human resources for electricity generation, transmission, and distribution that minimize the total cost of providing electric power to all classes of consumers, subject to engineering, market, and regulatory constraints. To analyze the definition, of course, that I would like to focus you on the following things. The first one, to provide electric power to all classes of consumers. However, some difficult situations happen with our electrical system. We should consider to maintain the safety of our grid. Therefore, some period of time, we should cut off some consumer and we should reform our grid. Other, of course, that we supply the power energy in a free market. So the cost for transferring energy to all the consumer is very important. So in the theoretical part, you can see in the picture, the generation, transmission, distribution, and consumer system. We have many kinds of resources participating to the electricity market, including the hydropower, hydraulic power, thermal power, and furthermore, nowadays there are more and more renewable energy resources, including solar cell, including wind power. So of course that besides solving the traditional electric power system issue, we should consider with the new renewable energy, and of course with the transfer energy from the renewable energy, we have a smart energy system. That's a reason why we have to take care this issue in this summer school. Now, the question is, where are we now? The fact of the smart grid today have to show for under following utility have made slow but steadily progress in optimizing their assets. Progress has been restrained by limited availability of the grid intelligence. Regulatory policy support asset optimization use or useful. For example, the question is, we use the thermal power plant or we use the hydraulic power plant. If we use all of the thermal power plant, of course that the cost will be very high. If we do not use the energy from the thermal power plant, we let all the thermal power plant shut down. When we restart it, because the system needs the support energy in the peak load situation. Of course, it's not very easy because the thermal power plant needs about 24 hours to start up. The smart grid technology and application create new opportunity for taking asset management to the next level. And the last one is industry is moving forward with many asset optimization initiative. Now, please look at the finger. In the finger, you will have the 5 levels of the average and ranks of many maturity score. And of course, that depends on the level of industry development in each country. People can classify the optimization progress in each country depending on the 5 levels. The aim of the optimization in smart energy system, we can summarize through our many research as well as many lecture books. The power system optimization is aimed at improvement in more areas than cost. It's focused on reliability. It's focused on efficiency. It's focused on economics. It focuses on environmental friendliness and it's focused on security. For example, to talk about the reliability, of course that we have very complex structure of the grid to determine and to identify what is the feeder, what is transformer substation we should cut off in the accident is not very easy, because today most of the power grid is interconnected. So if we make wrong decision, the reliability of our power system will be reduced. Obviously, it can lead to very serious economic issue or consequence. And about efficiency, turning back to example I talked some minutes ago, the relation between source of transmission, source of energy is very complex and it's very difficult to analyze. For example, hydraulic power sources, for example, thermal power sources, for example, energy, renewable energy sources. And similarly, to talk about environmental friendliness is not very easy. In some developed countries, people tend to use renewable energy power plant just because it's very good for environment. However, the budget for investment of this kind of the power plant is not very cheap. So how to harmonize the relation between the investment between the profit of environmentally friendliness bring is not very easy for all the operator, for all the manager, as well as for all the government. But with 5M, I would like to emphasize the priority of making decisions relying on the development of each country. Optimization will bring our very valuable area, the reliability, economic efficiency, environmental, and security is listed and you can see very clearly on the screen. To talk about the economic, by keeping downward price on electricity price, reducing amount paid by consumer as compared to the business as usual grid, creating new jobs and stimulating the US GDP. It is the conclusion implemented by the National US Development Department to talk about the economics of optimization. And efficiency, talking about efficiency, of course that optimization can reduce the cost to produce, to deliver, and to consume electricity. Of course, for example, I would like to talk about a very simple example to determine the location of a transformer substation. How to put the location of transformer substation. We locate it near the load or we locate it far the load. If we locate the transformer substation near the load, the investment for the real estate of the transformer is very high because it is in the center of the city. However, if we remove the transformer substation to another area far from the load, of course that we can reduce the investment for the area of transformer substation. However, we have to pay more for the power losses. So the question is how to show this optimization. Of course, to talking about the optimization, we should analyze the difference between the traditional grid and the smart grid. Smart grid is the future choice, of course. And if we solving our problem related to optimization, we have the following: decentralized supply and control. We have two-way power flow. We have two-way information flow. Why is two-way power flow? In the traditional grid, power is transmitted from the power plant to the consumer. However, today, with the existent, and there are more and more the smart grid. The solar panel located in some consumer can supply, self-supply for the consumer. However, in case the power is redundant, the power will be transmitted to the power system, and the consumer can get the money back from the power manager or the power corporation. To creating the intelligence and capacity to optimize, like I said before, if we create intelligence and capacity, we can optimize to get the reliability, security, economic efficiency, environment, and safety. And the question, smart grid is a future choice, isn't it? The answer is very simple, yes. Now, I would like to talk some technique for optimization in smart energy system. Many advanced techniques we can apply for optimization in smart energy system. The first is DMS. DMS is a platform for optimization. Applying DMS, the following can be get: common enterprises, network electrical connectivity model, geographic information system, supervisory control and data acquisition SCADA, and custom information system, engineering information system, and so on. And if we concern about the smart grid, we also concern about demand dispatch. Here is the table showing the smart grid characteristic and demand dispatch in a scenario. As you can see very clearly, if we think and we talk about the smart grid characteristic, for example, optimize access, utilization, and operate efficiency. In case demand dispatch, enable complex system optimization by allowing grid operator to dispatch both supply and demand to meet reliability, efficiency, economic, and environmental goals. Another is smart grid characteristic mentioned about operate resiliently against attack and nature disaster. For example, the lighting heat. So the demand dispatch generally can monitor and control demand resources, allowing faster restoration from outage, increasing penetration of distributed resources, reduces grid vulnerability. So the possible of the distribution architecture, we also have some kind of microgrid and the need of optimization. The picture shows you the two-way power transmit as well as the develop of the future of the sources. As you can see, a possible future distribution architecture can be listed as load flow, dispatch generation, and reconfiguration. Of course, that in this picture there are more and more microgrid, and of course microgrid is very small in our power network. However, it can contribute to the complexity of our network, and furthermore, to handle all the situation, all the consequence of this kind of grid developed in the future is not very easy, and it needs the operator, it needs all the planner think about the microgrid seriously. Now, to talk about the objective function of the smart and energy system optimization, the following objective function. The first one is power system planning. Power system planning depends on some kind of part of transmission energy to the consumer. The first one is about how long the transmission line. The second one is what is the location of the power plant. And the third one is what is the kind of connectivity between the power plant and the power plant to the consumer. And the last one is the location of the transformer substation. The next one is smart energy system optimization can help us to have maintenance scheduling. For example, in a vast and in a large power system, we have some kind of the power plant, so we have to make decision what time is suitable to make the maintenance for one power plant or for one type of power plant. Furthermore, maintenance scheduling can be easily to be done by restructure the grid. For example, we have a ring power system. Now we make this ring power system become a skeleton network, and of course that we have some transformer substation that are available for the maintenance. The next one is optimization can help us to optimal power flow or economic dispatch. Optimal power flow can bring some profit about reducing the power losses in the whole power system. Moreover, it can help all the operator to have economic dispatch to get the total amount of energy to supply fully to the consumer with the lowest price or lowest the cost of power generation. And of course, very important, optimization can help us to have the good and very nice solution for the network reconfiguration. Network reconfiguration will focus on minimum loss or loss reducing. However, in some case, network reconfiguration will meet the requirement of the reliability. The nice operation from the relay system. And the next one is optimization can objective on optimal reactive resources allocation. As you can understand, in our grid, there are two main kinds of the power resources. The first one is the active power. The second one is the reactive power. And to reduce the cost of power generation from the power plant, people have to use in medium voltage grid some kind of devices. It is reactive resources, and normally we can call it by capacitor. And to find out what is the right, the suitable and the appropriate allocation for located these reactive resources is always the matter and the problem on the engineer and on the technician care to get the largest profits. And the last one is the optimal protection and switching devices placement. Going along with the develop of the structure, we have some complex, and the complexity of the network will be increased more. So, of course, that the operator must care about the optimal protection to ensure that our relay system operate functionally and operate safety and operate reliability. And the last one, the objective function of the smart energy system is the population dispatch at the power plant. Of course, to talking about the pollution dispatch, it's not very easy problem. Like I mentioned before, it depends on the think about how to protect our environment. The first one I would like to mention about the optimal power flow. The technique to solve the optimal power flow problems based on mainly algorithm. And we have some kinds of methods. The first one is conventional optimization method. Second one is intelligent search method. And some of other is non-quantity approaches to address uncertainties in objectives and constraints. To show the optimal power flow, people should care about three types of buses. We will have PV bus, we will have PQ bus, and we also have the select bus. About the optimal power flow, you can further understand and you can have a chance to read more based on the presentation of teaching material of the project that uploaded on the website. Uh, Mention about three types of buses. You should remember the following. PV bus is active power P and the magnitude of voltage V are known, and the bus reactive power Q and the angle of the voltage must be identified. About the PQ bus, you have to know and remember active power P and reactive power Q are known. The other, the magnitude and the angle of the voltage must be identified. And the last one, slack bus, is very important. The slack bus is also called the swing bus or the reference bus, a bus with a zero angle of the voltage as reference for the calculation of other voltage angle. And normally, in a system, to calculate the optimal power flow, there is only one slack bus. To select the optimal power flow, you have to following the four steps. Optimal power flow means minimize and maximize a predefined objective based on the found of values of some or control variable. And as I mentioned before, we are normally have four variables. Maybe it is the magnitude of the voltage, or maybe it is the angle of the voltage, and maybe it is the active power, or maybe it is the reactive power. And among four variables, there are always two of them are pre-identified, and the other have to be determined. Proper problem of optimal power flow should be given at the onset with clearly stated objective. And objectives must be modeled and its practicality with possible solution. The quality of solution depends on the accuracy of the model study. And to show the optimal power flow, we can have the following methods. Newton method, gradient methods, modify interior point of optimal power flow, and the other. And all of the methods will have the different advantages and disadvantages. The detail you can find out based on the teaching material of the project uploaded on our website. And to mention about the optimal power flow, people should care about the following. We have the five following consideration. 1. Because of the consideration of large number of variety of constraints, and due to non-linearity of the mathematical model, optimal power flow poses a big challenges for the mathematician as well as engineer in obtaining optimal solution. Of course, today, with the development of some computing tools, especially the computer-aided programming, people can solve all the problem of optimal power flow very fast and very easily. However, do not think to use the hand solving with an optimal power flow. The second, the deregulated electricity market seek answer from optimal power flow to address a variety of different types of market participants, data model requirement and real-time processing, and selection of appropriate costing for each unbundle. The third, to cope up with response time requirements, modeling of externalities, loop flow, environmental, and simultaneous transfer, practicality and sensitivity for online use. And the fourth, how well the future optimal power flow provide local or global control measurement to support the impact of critical contingencies with threatened system voltage and angle stability simulated. And the last challenge is about future optimal power flow has to address the gamut of operation and planning environment in providing new generation facilities, unbundled transmission services, and other resources allocation service evaluation. To consider and to show the relation between 5 challenges is not very easy. However, remember, the setting value of optimization related to optimal power flow will be the following. The first one is total generation cost. The second one is the system loss. And the next one is the bus voltage deviation. And the last one is emission of generator unit. Depending on kind of voltages, for example, in the transmission system, I would like to mention about extra high voltage system. We don't care so much about the generation cost, but we care about the voltage, bus voltage deviation. However, to mention this setting value of optimization in medium voltage grid, people should think about the system loss or the bus voltage deviation, because two quantities are strongly affected to the power quality of the consumer. And to mention about the very last system, of course that the emission of generator or the unit of generator in a power plant will also our consideration. The need of optimal reconfiguration in a smart energy system is also the other side I would like to mention. Why we should care about the optimal grid structure? Because a large number of the power losses resulted from the low voltage level of the distribution system. Distribution systems are divided into subsystems of radio feeder, and the ways to enhance the voltage stability in the distribution system. So therefore, the need of optimal reconfiguration of smart energy system focus on the goal and the planning as follows. The goal of reconfiguration of the distribution network is to find a radial operating structure that minimizes the power losses of the distribution system under normal operation conditions. And about time of planning, we need to develop plans for new access to support increased demand, improve reliability, and the new interconnection, etc. Of course that people should think very clearly and seriously about the optimal grid structure in not only the time of planning, but also the time of develop our grid or our system, especially in the city. When you build up another area of the city, of course that we will have lost consumer, and we also have another connectivity of the grid. Therefore, we need new access to support increased demand and to improve the reliability. Maybe sometime we should think about the structure to make sure our relay system operate functionally. To identify the problem, the objective of the problem in optimal grid structure is to get maximum power loss reduction in distribution system due to reconfiguration and improvement in voltage. So of course that we also have two kinds of the objective function. The first function is maximize F. We can have maximize voltage loss. It means that we have to reduce as much as possible the power loss, including active power and reactive power and apparent power. And we also solving this minimizing losses subjected to current, voltage, and power loss constraints. The following constraints could be plant current constraints, should be node voltage constraint, and should be active, reactive, and apparent power losses. You can see on the screen, this constraint is very typical and very popular in every power system. And the other is about voltage stability. We have some solution to show the problem of optimal grid structure. One of the recommended solution is distribution network reconfiguration control. You can have two kinds of variable here. The first one, we can use the current variable, and the other is U power variable. And as you can see on the screen, here is the objective function as well as the constraint related to current and voltage in X buses. And in the following equations, we have the definition. P is reactive power or real power. P is the active power or real power. Q is reactive power. R is the resistance of the plant. V and I is the voltage and the current respectively of a node. And K is the topological status of the plant. N, the set of the nodes. And NL, the set of branches. Min and max, the lower and the upper bounds of the constraint. The constraint can be classified into the plant real power, the node voltage constraint, and the Kirchhoff first and the second law, and the topology constraint. And with this constraint, with the objective function, you can use some method mentioned before to get about optimal grid structure. Here is also the explanation about the constraint. Include power loss, the plant active power and reactive power constraint, and the Kirchhoff first law. So some popular method I would like to show you. You can find out the detail. Is heuristic methods, mixed integral linear programming, and rule-based comprehensive methods. General analyzing of optimal grid structure. By advanced techniques, you can talk about startup sequence of generating unit skeleton network and optimize the restoration path with restoration constraint. The methods are taken into account of optimizing the network reconfiguration. Here, there are 2 or 3 methods. So, power system resilience definition will be the following. The first one is anticipation. The second one is absorption. The next one is restoration. The fourth one is adaptability. And with this one, we will have resources, resourcefulness, rapid recovery, robustness, and adaptability. Here is analyzing of this kind: resourcefulness, rapid recovery, robustness, and adaptability. The scope of the grid resilience becomes large and cover various features such as technical, economic, social, and policy. Technically, it includes multidisciplinary knowledge such as power system, civil and structure, geography, computer science, probability, and meteorology. The study of the grid resilience also relates to many organizations such as utility, corporation, disaster management agencies, and national weather services. The impact of interdependency with other areas is beyond the scope of this review. Many papers and research and many books mention in the area of power system resilience and by many institutions. Another definition based on inherent feature of resiliency and the property of the power system is defined as resourcefulness, rapid recovery, robustness, and adaptability. The relation between resilient feature and the power system restoration application you can see on the picture on the screen. The power system resilience involves two typical structures such as grid assessment and grid enhancement. For the first one, grid assessment is used to evaluate the grid condition by using hazard modeling and results in grid resilience indices and to compare one grid to another and then to further determine necessary action to enhance the grid resilience. There are four conditions for grid assessment process: anticipation, prevention state, absorption, degradation state, restoration state, and adaptation state. For the second one, the grid enhancement approaches can be implemented on physical hardness and operational capability system of the power grid. Restoring the power system within a short period of time is the objective of grid operational capability after power system blackout. Optimal network reconfiguration problem for grid resilience can be evaluated by using many approaches such as indices and optimization technique to help operator for evaluating the recovery options and implementation. It is important to reconfigure the power grid for customers after a complete blackout, attack, or disruption. In the following, complex network theory-based indices used for power system network reconfiguration have been further discussed. Second, optimization models and techniques used for network reconfiguration of power system have been presented and also analyzed. So, of course, that reconfiguration a network will have very profit to the operator. Also will bring some challenges to the operator. How to handle this problem very useful. Turn back to some following slide to mention about general analyzing optimization of grid structure. One important concern is that the node and the edges in the network have different network connection and their function. And why? Now a question arises: how to detect or identify critical nodes and links in the network and their impact on the network topology of the power grid. People suggest that as long as 4% of the total nodes with a large load in the power grid breakdown, the connectivity of the power grid will decrease by 60%. Note and line important evaluation contribute to the targeted protection of important nodes and link in the power grid. Not important and degree and efficient indices have been used for network reconfiguration. A self-healing transmission network reconfiguration algorithm is also the thing people consider. And not important based on concept of regret have been proposed in many research as well as in many lecture books. Similarly, the line contraction concept have been used for evaluating the importance of various lines. Furthermore, the node important degree based on node contraction had also been used to build a skeleton network. There are three phases of optimization network reconfiguration, such as startup sequence of generating unit, skeleton network, and then to optimize the restoration path, taking all restoration constraints into consideration. Some other techniques, such as artificial intelligence, can be used in the network reconfiguration process to restore the power system quickly within a short period of time. Decision-making method also has been proposed with the aid of the computer, with the aid of the artificial intelligence to show network reconfiguration problem. Those methods were applied to evaluate the unit startup sequence, to build the skeleton network, and to obtain restoration paths, aiming to obtain the global optimal solution and to obtain optimization structure. Techniques such as numerical methods and optimization algorithm will also be analyzed in the next following part of this lecture video. Now, I would like to mention about the first theory, complex network theory, based indices for smart energy system reconfiguration. In this section, there is a discussion about indices based on CNT framework to evaluate the node important and the edge important for the network reconfiguration problem. Some of them use only pure topological Bayes indices. Others propose both pure topological as well as extended Bayes indices. Complex network analysis consists of a set of node connectivity and connected by a set of line or a row. Any power system network can be represented as a graph, where V denotes the vertices of node, E indicates the edge or link, and W represents the weight of edge. So, the complex network theory can concern with two groups of centrality. Two groups of centrality in complex network theory are closeness of node or edge, such as degree centrality and closeness centrality. Evaluation of the time between two edges or two nodes, such as flow between this centrality and efficient shortest path. And here are some analyzing about CNT, complex network theory. CNT can be used to solve many problems by reducing the problem to a standard graph problem. An optimal solution can be provided by making use of CNT-based algorithm. There are many algorithms used for solving complex network problems, such as a trivial algorithm, degree clustering coefficient, degree distribution, and so on. Shortest path algorithm, Freeman betweenist, X betweenist, Riska algorithm, and so on. And these methods you can find out by reading the reference document very last class of this lecture video. Moreover, centrality measures are used to quantitative indicate important nodes and lines in complex network problems. Centrality can be categorized into two groups in CNT. The first one is a closeness of node of edge, such as degree centrality and closeness centrality. The second one evaluates the time between two edges or two nodes, such as flow betweenness centrality and efficiency, shortest path. Centrality measures are used to quantitative indicate important nodes and lines in the complex network problems. In CNT-based algorithm or in CNT-based problems, The most used centrality measure indices are degree centrality, electrical degree centrality, eigenvector centrality, clustering coefficient, closeness centrality, electrical closeness centrality, betweenness centrality, electrical betweenness, and efficiency. The individual who has more link with another node or more information is defined as degree centrality, and it evaluates the structure importance of nodes. Furthermore, electrical degree centrality, the node which has more link, number of transmission lines connected, means power flowing in the adjacent link has more information as compared to other nodes. Eigenvector centrality is used to identify the significance of the node if it is connected by another important node. The clustering coefficient measures the degree by observing nodes in a graph that tend to cluster together. Closeness list centrality determines the degree to which a node is close to all other nodes in the network, or to quantify the independence of various nodes. Line impedance is used to determine the shortest path between pair of nodes that run through that edge or vertex of the grid. Betweenness centrality of node or edge is employed to determine the hub of one node or edge in the topology of a complex network, either because of their location in the grid or by the amount of power they convey. This measurement can be described the importance of a node or edge by identifying the number of the shortest path between pair of nodes that run through that node of edge. This means that the larger the node or the edge between it is, the more important role the node or edge plays in the network. Many shortest paths among all pair of vertices in the network would become longer when the node or edge with the maximum betweenness is removed. Efficient index is used to identify the tolerance of the power grid and the performance of the power grid by identifying the critical nodes or edges whose removal causes the biggest drop in the efficiency of the power system. So to summarize about the centrality, we have the following. Here we have the merits and demerits of each method that can use to analyze or to solve the problem of complex network algorithm. We also have electrical degree centrality. We also have eigenvector. We also have clustering coefficient. We also have node important and line important degree. And the method of the centrality focus on electrical degree centrality, eigenvector centrality, clustering coefficient, node important degree, line important degree, and important degree of a node. And this is very not easy for you to cover all method that solving the complex network CLT based algorithm. I do hope that by discovering all the detail with the reference document that written in some paper or some lecture note or some online access book, you can find out very clearly this matter. So as I mentioned before, efficiency for network reconfiguration is need an evaluation. So here the following is some evaluation methods or functions that estimate the efficiency of the reconfiguration. The objective efficiency you can see on the screen based on the length of transmission lines with the consideration of the load node. And of course that to solve this you can have some following mathematical tool, or you can have some technique relying on the computer aid. Another efficiency for network reconfiguration is the network efficiency centrality of node U. It defined as the follow with some component you can see on the screen. However, definition used for some decision variable for transmission network reconfiguration is the following. We have many variables, and all of these variables will contribute to the function of evaluating efficiency. Modern power systems become more vulnerable due to higher blackout risk, which can affect society. To consider the main issue in terms of security of the power system after a complete blackout, black start and restoration of power system play vital role. There are three stages of transmission network reconfiguration, that is, startup sequence of generating units, second latent network, and optimizing the restoration path with the satisfaction of all restoration constraints. The main objective of the startup sequence of generating unit is to maximize the restore generation capacity. The generator startup sequence plays a key role in the restoration strategy that determines the time consumed in power system restoration, accelerating the system recovery. In generator startup sequence, the non-black start generators are cranked through black start generator via transmission line. And here another definition to talk about the startup sequence of generation unit model. The objective of the startup sequence of generating unit is to maximize the restore generation capacity. It is main phase of the network reconfiguration phase and is formulated as the function you can see on the screen. Secondly, the restoration path play a vital role in the network reconfiguration to build cranking path, restoring transmission line one by one. The goal of the optimization of restoration path is to maximize the load served at all time, to minimize the restoration time, to minimize the number and the magnitude of the control action to be taken, and eventually to form a skeleton network. An optimized restoration scheme will assist system operator to build a skeleton network for restarting unit and restoring power supply to important load. So there are 5 constraints of this method. The first one is generation output constraint. The second one is the constraint of the voltage amplitude and the phase angle at node. And the third one is the constraints of transmission line capacity. The next one is the constraints of the system frequency. Normally, to maintain the reliability of the whole system, the frequency of the system must fall within the minimum allowance value and the maximum allowance value. And normally, it is 2% of nominal frequency. And the last constraint is the constraint of the critical maximum interval of a generator. These coordinated 3 objects that you can see on the function, such as startup sequence, network reconfiguration, and load recovery, in the form of mathematical model can be presented as the last equation on the left of the screen. So restoration path model is proposed to minimize the restore wasted energy path for unit startup or load recovery by evaluating the sorted path between specified buses in one time step and formulated as the function you can see. The goal of the optimization of restoration path is to maximize the load served at all time, to minimize the restoration time, to minimize the number and the magnitude of control action to be taken and eventually to form a skeleton network. In this function, we will have the following limit: the limited capacity of available power sources. The second one constraint is about the power balance between supply and the demand. And the third constraint of restoration path model is about plant capacity constraint. And the next one is the skeleton network model. The skeleton network model also contains 5 constraints. The first constraint is about the time constraints. The second one is about generation output constraint. And the next one, and as the third one, is the constraint of burst voltage amplitude at nodes. It must be very remember for the student that depending on kind of transmission or distribution grid, this minimum allowance value and maximum allowance value of the voltage, it will be very different. For example, in the transmission system, it is about around 10% around the nominal voltage value. However, in the distribution grid, it is only the 5%. And the fourth constraint is about the constraint of transmission line capacity. And the last one is about the generator excitation constraint. This generator excitation constraint makes sure that all the generator can work properly during the skeleton network happen or form. So there are 3 phases of optimization of network reconfiguration to obtain the startup sequence of generating unit, to build the skeleton network, and to optimize the restoration path with the satisfaction of all restoration constraints. And to solving this one, we can have some of the following methodology. As you can see on the screen, it can be nonlinear, mixed integer linear, multi-object optimization, or some lexicographic method, discrete particle swarm, or genetic algorithm, or taboo search algorithm. Each of these methods will have the merit or demerit, or will have advantages or disadvantages. Nonlinear programming also has been applied to optimize the network reconfiguration problem. Mixed integer quadratically constrained program has been proposed to solve the startup sequence of the generators for each time step. Mixed integer linear program proposed for startup sequence of generator is proposed to find optimal load tap switching and transmission line charging considering security constraints, and to obtain the optimal solution of pickup and charging the predetermined loads and transmission line by finding system frequency. The objective of method is to optimize the line, the restoration path for network reconfiguration. Mid-integer programming is used for optimal substation reconfiguration model. The objective is to minimize the cost by satisfying parameters such as direct current, power flow, and phase angle to minimize the sum of branch overloads with consideration of line switching performing cost. Multi-objective optimization have been proposed to solve network reconfiguration problem for 3 optimization sub-problems. The objective of the network unit layer is to restart the plant with larger capacity. It means that with the larger active energy output, to maximize the total weighted energy output that the system can provide during the network reconfiguration period. The lexicographic method is used to obtain the optimal value by the ranking of all objectives according to descending order. It helps to optimize the objective function on the basis of reserved previous optimization results. The main objective of the proposed method is to maximize restoration generating capacity in the limited time of the skeleton network. Inside this one, the objective of the minimization of active and reactive power losses for improving the voltage profile at each burst in the power system network reconfiguration and solved by Newton-Raphson rod flow technique. Some optimization algorithms used for power system network reconfiguration are very popular. A discrete particle swarm optimization algorithm has been proposed to restore and concern backbone network, subsystem interconnection, and build a stable skeleton network are three objectives of network reconfiguration. Discrete particle swarm optimization proposed to obtain main network and quick load restoration to determine the skeleton network, and also many optimal schemes for power system restoration instead of restoration path sequence by using efficiency index. The objective of the particle swarm optimization algorithm is to find the optimal restoration sequence of the unit and load to be restored, and the objective of the fuzzy simulation is to check fuzzy constants. The genetic algorithm has been proposed to solve network reconfiguration problem. The objective of the proposed genetic algorithm is to minimize the sum of branch overload with consideration of switching performing cost to obtain optimized skeleton network for power system is main objective of this method. And it also maximizes the reconstruction efficiency to detect congestion with less ring power losses. The objective of the proposed genetic algorithm is to minimize the power transfer distribution factor to find an optimal path for skeleton network to minimize the index L value. Another method will also be analyzed. You can find out on the reference document very last at the end of the video lecture. So of course to solving the problem of network reconfiguration, we also have to face with practical challenges, issues, and industrial practice. Here are some challenges. We can have some common issue during the restoration. It could be active power balance and frequency control, reactive power balance and over voltage control, transient switching voltage, and so on. And of course that all of these challenges will bring more and more consideration as well as more and more constraint for the people to solving the problem of optimizing the restoration of the network. Power system blackout may occur due to overloading, voltage violation, cascading failure, or even loss of stability, and for system operator to take appropriate counteractive control action. Several major types of challenges and technical issues are shown on the screen, respectively. The main challenges like transient security, such as voltage stability and compensation in energizing long-distance transmission line with light or no load, tight line phase angle or synchronization, switching surge, and so on. Moreover, steady-state security challenges such as active power balance, reactive power balance, thermal stability, voltage stability, generation selection, line rerouting, and reliability. These challenges and issues need to be considered and managed in terms of power engineering during the power system restoration after the blackout. The restoration process can be quick again, partial outage, but it may be a significant barrier itself against extensive outage. Regulatory issues are controlled by the directive from the authority in charge of deciding the specified level of service reliability to be provided by the utility to end users. Service reliability can be affected by the inappropriate restoration action such as repeated failure, insufficient knowledge of the system to fast restoration. This consequence can give a brief overview of the regulatory issue faced during the power system restoration, that is, can be the following. Most inappropriate restoration action, such as repeated failure due to unexplained strategy or direction. That is lack of awareness of such emergency at substation level in the network reconfiguration phase. This issue also can be encountered by proactive mobilization of staff and adequate replacement equipment in inventory to minimize downtime. Service reliability due to the insufficient information on the failure circumstances. This issue can be improved by the proactive mobilization of staff. This issue can be handled by mobilizing dispatching staff to critical station and backup control center. Regulatory authorities generally establish the standard criteria and requirements for power system network reconfiguration. Each country will have different criteria and standards to overcome these regulatory issues. And here, the challenges will be so if we have some other care and some other attention. The first one is understanding of the sources, power plant, PV sources, loads and tie switches. Or the second one is an objective identification, and the next one is a mass model to solving with constraint. It will be analyzed if we consider the following case. The objective case here, we have a grid. With the single line diagram, and we can divide this grid into 3 loops. Building up the objective function of this loop, we will have the function to minimize of F1, F2, F3, and F4, where F1 is the line loss, F2 is voltage deviation, F3 is energy wastage from the solar PV by distributed generator due to varying power factor operation, and F4 is this energy wastage from wind by distributed generator due to varying power factor operation. And the grid you can see here stand for a complex network with the transitional power source, thermal power source, hydraulic power source, and also it includes some renewable source. As I mentioned, it is a PV source and the wind source. And of course, to solve the problem of restoration as well as multi-objective optimization, the function of objective will be built and formed. The first one you can see very large on the screen is the objective function of F1. The next one, it is the minimization of voltage deviation. It is called F2. The number 3 is the minimization of reduction of active power generation from distributed generator. And the last one, it is the F4. It is wind distributed generator also. The constraints, we have 4 constraints. The first constraint is the power balance. It means that the power generated by own source must be bigger or equal with the power consumed by the end user. Similarly, it is reactive power. The second and the third constraint is about the burst voltage operating limit as well as the line current limit. And the last constraint is the radiality of distribution network. So What is different if we show the problem of multi-objective optimization in distribution network? Despite of showing this problem in transmission network, here are the analyzing. Electric distribution network differ from the transmission network in various aspects. As I mentioned follow, there are four differences. They usually have the radio network structure. The second one, the load they serve is usually non-uniformly distributed. And the third is the distribution network usually have an extremely large number of branches and nodes. And the fourth, they may have a wide variation in resistance and reactance value for all branches. It all will create very complexity of solving the problem in the multi-objective optimization. However, some method will be proposed to solve this problem. One of the optimization method is non-dominated sorting particle swarm optimization. To show it, you will follow 9 steps as you can see on the screen. From the beginning is input time frame, and the last one is end and print the result. And to mention about this optimization, I do not want to go further about algorithm. I would like to show you some results to prove the effectiveness of this method. Here are the results when we apply multi-objective optimization. You can see on the screen, it is the table. That number, the switches open, maximum voltage deviation, number of switching operation, and total light loss. The method is compared with the reference by the traditional or other methods. And of course that obviously, you can see maybe for example in the last column, the total light loss will be smaller, very significantly. The number of the switching operation in the closed last column is very ideal, and sometimes the number of the switching operation maybe is bigger, but it can bring you bigger profits by reducing the power losses. About the maximum voltage deviation is also smaller. It means that the technical parameter of the grid is improved. Similarly, another result of the tie switch operation with distributed generator power factor at normal loss is also shown on the table. And you can see that all of the power factor of wind distributed generator is improved. It is higher so much and as normal. By comparing results in these two tables, it can be observed that power factor are better in later case due to obtaining different optimal opening position of tie switches. And here, reconfiguration has positive impacts and that able to reduce wastage of renewable energy from solar and wind distributed generator. Similarly, it can be observed that overall power factor are improved even at increased loss level due to combining together with different optimal reconfiguration of tie switches. And hence, reconfiguration has positive impact and that able to reduce wastage of renewable energy from solar and wind distributed generator. Certainly, few tie switches are open at different time period due to effect of load and generation profile. Now, I would like to show some very shortly about the case study related to optimization. The first case study is the optimal capacitor placement, and another is a case study about optimal distributed generator reconfiguration. However, because limited of the time, I don't have much time to show all the detail as well as the method to get the result of all of these cases. However, I would like to show you very briefly how to use a computer app or a software. They are very effective tools that help us to solve all of our optimization problems based on the theory we understand. The first one is case study 1, optimal capacitor placement. Now, let's see. This is the medium voltage structure grid in Vietnam with the nominal voltage of 22 kilovolt. The request and the objective is to determine the location to locate the capacitor for reducing the power losses in the medium voltage and to improve the voltage at the very end user of the line. Making the simulation on ETAP application, it is very popular. You can build up this grid with the parameter can be inserted and can be set very easily by the software. And in software, you can see on the taskbar there are many tools that help us to calculate. And the first one, after finishing the simulation, please calculate the power flow. And after calculation, the farthest point here, you can see the voltage deviation is very great. It is about 88.25%. It means that the voltage will be reduced over 10%, nearly 12%. So the objective and constraint and the grid parameter of the case study 1 is about, the first one is voltage deviation. Voltage deviation in every buses must be smaller than 5%. It means that the voltage will be fluctuate from 95% to 105% of the nominal voltage. The energy price is about 8 cents for 1 kilowatt hour, and interest rate of the bank is about 4%. Lifetime of the capacitor will be operated in about 10 years. And of course, we also have the objective constraint of the load level. We have 3 different load levels: peak, idle, and normal. It's about 110%, 90%, and 100%. In the time period, you can see here, it's about 25, 20, and 55. So the question is, what is the 5% left in time? I will let you answer this question. The nominal voltage of the grid is about 22 kilovolt, and the capacity, it means that the capacitor unit is about 300 kVAR. The price is about $25 for kVA investment. Installation cost is about $1,600. Operation cost for a year is about $300 for a year. So setting up the processor. After setting up the processor, you can choose the window project on, as you can see on the right side of the screen, and then choose the setting. And then next one, you can choose loading and generation category. And then you can go through the setup processor. In the setup processor, you can have the table that describes the load, the generation, and as well as other parameters. And after setting up finished, you can see here on the taskbar, you can choose the optimal capacitor placement. It is near the middle of the taskbar, as you can see on the screen. After clicking on this button, of course that the diagram are ready to run. However, we don't have any constraint consideration. So how how to set up the constraint. So please look at on very upper left corner of the screen. You can see a case, red case here. When you click on there, you can read it, edit study cases. When you click on this, you can set up all our constraints. For example, here, you can have the constraints of load. You can have constraint of voltage. You can have constraint of power factor and capacitor and adjustment. And each of tab will show you some optional or alternative that very easily for you to set up. And here is an example of setting up the constraints. I set up the constraint is all the bus is about 22 kilovolt or not lower than 5%. And after setting up the constraints, recalculating the optimal power flow, recalculating the optimal capacitor placement or optimal capacitor allocation, we will have the result here. And we can analyze another about the power flow. So the result is improved. Voltage deviation is only 90.3% compared with about 88.25% in previous simulation. It means that the voltage is improved. Here is about the summary result. Optimal capacitor placement result show that we will have here is 8 buses to determine. However, after the computing process, only 2 buses. It needs to locate a capacitor bank. It is B6 and B8. Another result can be deducted from the software. It is about the branch losses summary report, and it shows that all the technical parameter of the grid is improved very significantly. And here it is the optimal capacitor placement cost summary. So one of the assignment I would like to give you that please by your group or by your side create a medium voltage grid with the load in different phenomena, different peak, idle, and normal situation, and then use the suitable software or suitable computer app to simulate or to determine what is the nice and what is the best location to put capacitor. After determining the optimal capacitor placement in your grid, please calculate again about the technical parameter of the grid, including voltage deviation, including the current running through in the life. And of course, you should calculate about the money, about the profit, especially economical profit that our activity can bring. Of course, that I can recommend some very useful software for you. The first one is ETAP that you can see throughout my lecture video. The second one is you can see you can use MATLAB, and there are more and more another software. It depends on the mentor in your university. And I would like to recommend that this software is funded by the project and is very popular in 2 universities in Vietnam who are the partner of the project. And another case study is optimal reconfiguration of 22 kilovolt Vietnamese distribution grid. It is the grid in Điện Biên City. As you can see on the screen, the grid is very complex. The question is how to find out the nice and the best structure, optimization structure of the grid that can help the operator to maintain the reliability as well as to reduce the power losses. And here it is the recommendation. We have another optimization structure with another line connected with 2 feeder to improve the voltage profile as well as to reduce the power energy. And maybe I will ask another partner of the project to deliver this exercise to all the student participants. If the answer say yes, of course that we will have another project assignment. Now, in 1 hour and a half is not enough for me to cover all the matter related to optimization, as I mentioned before. However, I do hope that I bring you very briefly understanding about what is optimization. In summary, to solving the optimization problem in a power system, including medium voltage or transmission system, you must determine. The first one is about the objective function. The second one is about the constraints. And the last one, what is the suitable mathematical solution that you can use to solve. And here is also the reference list of my lecture note. I can deliver this reference list to all of the students of summer school by giving it to our students. In Hanoi University of Mining and Geology, we also have two groups of the participants, and they will please keep in touch to share all of this reference because it is very useful for you. Of course that the reference is not long enough for you to read all, but to understand all of them is not very easy. Thank you for your attention. In 1 hour and a half, I am not so ambitious that I can cover all the knowledge and understanding about optimization. But I really do hope that I give you very briefly introduction about optimization. Remember, to optimize some problems, you must determine what is the objective function. The second one is the constraint, and the last one is what are the methods or the computer add solution to solve the problem. And of course, I'm very happy to be one partner, one member of this summer school. I do hope that in the future I can welcome some of you to Hanoi University of Mining and Geology to have an academic exchange or cultural exchange, and welcome all of you to Hanoi, the capital of Vietnam, the city of the peace, and have a good day with summer school. See you on online consultant meeting next time. Bye.